Hey, it's Mr. Shrum, and I'm back again with a tutorial walkthrough, and we're going to finish up the electromagnetic spectrum. And we're going to look at visible light now. So let's get into it. Humans can see only a narrow range of electromagnetic radiation, and we call this the visible spectrum. When white light passes through a prism, it is split apart into its separate wavelengths. Each wavelength is seen as a slightly different color, and each has a specific frequency. The bands of color you see are the same as those found in a rainbow. From right to left, these colors are red, orange, yellow, blue, indigo, and violet. The acronym ROY, G, BIV might help you remember the order. And we go right to left. A typical human eye can see electromagnetic waves that have wavelengths ranging from about 380 nanometers, violet, to 750 nanometers, which is red. So longer wavelengths, reddish, shorter wavelengths, violet. And that equates to frequencies of about 4 times 10 to the negative 14th hertz, which is red, to 7.8 times 10 to the negative 14th power hertz, which is violet. All the colors of the visible light spectrum fall within this range from left to right. On the visible light spectrum, the frequency of spectral colors decreases while the wavelength increases. Red and violet are the two extremes on this spectrum. Red has the lowest frequency, longest wavelength. Violet has the highest frequency, shortest wavelength. Which color of the visible light spectrum has the highest frequency and the shortest wavelength? Let me see. Oh, it's violet, because we just said that. Infrared radiation. The visible light spectrum is flanked by infrared and ultraviolet waves. Infrared, think of infrared as going past red and ultraviolet being past violet. So infrared will be over here with the red, ultraviolet will be past the violet on the left. Infrared waves blend with the red light on one end of the spectrum. The ultraviolet waves blend with the violet waves on the other end. Infrared waves have wavelengths of roughly 0.750 to 300 micrometers. That's longer than red light, but shorter than microwaves. Infrared waves with wavelengths closer to the red light are called near infrared. Those with wavelengths closer to microwaves are called far infrared. If you've ever seen night vision glasses used by military and law enforcement agencies, they can detect human presence in the dark. With these glasses, you can see infrared light emitted by skin and by other warm objects like vehicles, buildings. Humans aren't able to detect most of the infrared waves emitted by the sun since the rays can't penetrate the atmosphere. However, telescopes at higher elevations and those in space, like the Spitzer Space Telescope, are able to detect infrared waves from the sun and stars. So, on the other side of the spectrum, we have UV, ultraviolet. And those wavelengths are roughly from 10 to 400 nanometers. These wavelengths are shorter than violet light, but longer than X-rays. The sun emits UV waves in three recognized energy ranges: UVA, UVB, and UVC. UVA has the longest wavelengths, UVB have the next longest, and UVC have the shortest and highest energy wavelengths. The atmosphere blocks most of the sun's UV radiation, including all UVC. About 95% of the UV radiation that reaches Earth is UVA. The rest is UVB. Some UV radiation is beneficial. For example, we have UVB rays that help produce vitamin D, which helps metabolize calcium in your body. However, overexposure to UV radiation can be harmful. It can cause a range of mild problems like sunburns to serious illnesses such as skin cancers. To prevent its harmful effects, you should use sunscreen. Most sunscreens come with an SPF number. SPF stands for sun protection factor, and it gives you the number of its magnitude. And this video talks about UV radiation. You guys can watch that on your own so I don't get copyright stricken again. And yeah. All right, so we're at the summary. The electromagnetic radiation travels through space as electromagnetic waves. The electromagnetic spectrum includes radio waves, microwaves, infrared radiation, visible light, ultraviolet radiation, X-rays, and gamma rays. Electromagnetic waves with long wavelengths, such as radio waves, are produced by oscillating electrons. The frequency of the wave is directly proportional to the oscillation frequency of the electron. On the atomic scale, so the very small scale, radiation is also emitted when electrons change their energy states, moving to atomic orbitals with higher or lower energy values. No matter what type of radiation, however, the energy of electromagnetic radiation is directly proportional to its frequency. Gamma rays with high frequencies and short wavelengths have high energy. Radio waves have low energy. A narrow range of wavelengths on the electromagnetic spectrum belongs to visible light. The colors of the visible spectrum range from red to violet. Remember Roy G. Biv. And each color has a different range of wavelengths and frequencies. All of the colors in this spectrum combine to form white light. Red and violet lights from the two extremes on the visible spectrum. Red has the longest visible wavelengths. Violet has the shortest. Infrared radiation has wavelengths just longer than those of visible red light, but shorter than microwaves. Ultraviolet radiation has wavelengths just shorter than those of violet light, but longer than X-rays.